our gear blank Anjali. Initially we have a gear blank na? And later on we have generated the teeth on its periphery, and after generating the teeth the gear look like this na Anjali, suppose the teeth look like this. Okay,
Yes, sir.
and I'm drawing the half of the diagram so that you can understand what is the gear. So pitch circle is an imaginary circle. First thing is that pitch circle is imaginary circle, Anjali. This circle doesn't exist actually. And you are saying,
Yes,
sir,
sir.
that the gears are classified or differentiated due to this parameter. Yes, this is an imaginary circle. We do assume that this circle is passing right through the middle of the teeth of the gears. Okay, and in the direction in which the gear is
Okay.
rotating, this pitch circle is also rotating, direction of rotation of gear, and this pitch circle is same na? Obviously it is same because we are assuming it is on teeth. It cannot happen that na, the inside part of gear is rotating clockwise and teeth are rotating anti-clockwise. No, it cannot be there. Okay, so
Yes, sir.
the pitch circle is an imaginary circle. Okay, in the gears, in the middle of the gear teeth where the pure rolling motion is observed. Okay, why this circle becomes important? Because if you want to see the pure
Okay.
rolling, then only and only whenever the two gears are meeting, so their pitch circle is also in touch with each other. Okay, and it cannot be the
Okay.
physical characteristic of gear, but it is being most important circle. Okay, it is one of the biggest specification of gear, you can say. Okay, and any size of gear is
Okay.
specified by the dia of pitch circle. Okay, on in the market you will say, sir, my gear pitch circle diameter is 60 mm, so automatically he will provide you the gear. Okay, that's why the gear size is specified by the
Okay.
dia of pitch circle. Okay, so let me show you where is this pitch circle. So this is how
Okay.
this pitch circle look like. Suppose this is my pitch circle. Okay, and that where the teeth are being situated, teeth are being situated in this way, Anjali. Okay, this is the first teeth, and suppose this is the second teeth. So we need to draw only two teeth to understand the gear terminology. The topic name is gear terminology. Okay, so this is the teeth part. This is the, you can say, back part of the teeth, and this is how the teeth look like. And you can say that this is the remaining part. This is how. Okay, so one by one I will tell you how the parts are there. So this blue circle is what, Anjali? Pitch circle. P dot C dot pitch circle.
It's
So on the top of the teeth, Anjali, on the top of teeth, the line joining the top of the teeth, a circle could be drawn. A circle could be drawn, and this circle is known as, Anjali, what? Addendum circle. A dot C. Addendum circle. A double
okay.
D E N D U M. Have you heard about this parameter? Obviously, you have heard about addendum circle. And where is
Yes, sir.
the, there is a dedendum circle also. There is a dedendum circle also, so that we can understand that where is this dedendum circle. Okay, this dedendum circle lies just at the bottom of the teeth, you can say, at the bottom of teeth, but just below the, below over here. So let me show you in this diagram. This is the root of, you can say, the bottommost part. Okay, so let me show you with a different pen so that you can understand. This is my dedendum circle, Anjali. This is my dedendum circle, and the diameter of dedendum circle is known as dedendum circle dia. That's it. Dedendum circle. So above the pitch circle, addendum
Okay.
circle. Below the pitch circle is the dedendum circle. This part is known as, Anjali, top land of the teeth. Top land. I already told you in yesterday class also. So this length is, Anjali, this length is known as face
Yes, sir.
width. Face width. Okay, face width. But these parameters are hardly used in theory of machine. They are being used in our, you can say, machine design. Okay, So addendum circle, pitch circle, and addendum circle is clear, na Anjali? So now there is smaller parameters which I one by one I will tell you. Whenever the teeth is starting over here, Anjali, the teeth is being started at this point, na, and two consecutive teeths on this pitch circle. The radial distance, Anjali, the radial distance between the starting point of the one gear and the uh, corresponding next teeth. This radial distance is known as, Anjali, what? Circular pitch. Okay, this thing, Anjali, radial distance. Remember this thing. Radial distance on pitch circle. Two consecutive teeths starting point is the main function over here. So this distance is known as the circular pitch, and the most of the numerical include this circular pitch every time. So radial distance, not straight distance, circular pitch. Can you see that, Anjali, that this what? Tooth thickness or not? Tooth thickness is this one, na Anjali? Tooth thickness.
Yes, sir.
And can you understand this one also? This is our tooth space, Anjali. This is our tooth space, the space between the two consecutive teeth.
Okay.
So can't I say that the circular pitch is the summation of tooth space and tooth thickness? Obviously, na, circular pitch is the radial distance on the pitch circle from the starting point of the one gear teeth to the next gear teeth. Okay. Now the tooth thickness and tooth space summation is also known as circular pitch, and both are the radial distance. Both are the radial distance. So can you say that, Anjali, if two gears are meeting, the tooth space of one gear is exactly equal to the tooth thickness of the other gear, then and then only other gear can enter between the tooth space of the other gear, na? Otherwise it cannot enter. Suppose you are entering a house and the door is so narrow that you cannot enter. So how do you enter? So this means whenever two gears are meeting, or you can say meshing or engaging with each other, so the corresponding tooth space must be equal to the tooth thickness of the other gear. Otherwise the motion cannot be transmitted. Okay, this thing you need to understand. So there is a other parameters also. This part is known as what, Anjali? Face of the teeth, and the bottom part is known as flank of the teeth. But the face and flanks are the small terms. The remaining terms is, Anjali, what? Addendum, and the other thing is dedendum. But there is another more important parameter, that is clearance circle. Okay, there is a clearance circle also, Anjali, clearance circle. So let me draw with a black pen. So clearance circle lies just above the dedendum circle. This is the clearance circle. This is the clearance circle. Why do we have a need to define this clearance circle? CC. See, Anjali, whenever the teeth of one gear is in this way. Okay, so my requirement is that whenever other gear come into the meshing of this gear, this point should not touch, Anjali. Otherwise, the teeth can damage. So I need to provide some clearance. I need to provide some clearance, little clearance, this clearance, Anjali, so that this distance could not touch with each other. And this condition is for both the gear. Okay, this gear teeth and this gear teeth, there should be a clearance between the tooth tip and the root of the other gear. Okay, so that the circle passing through the tip of this teeth is known as clearance circle. So this distance, actually, this vertical distance, this time I am talking about the vertical distance. This distance is known as, Anjali, what? Addendum. Okay, addendum is this distance, and this distance, Anjali, vertical distance, is known as dedendum. D-E-double-D. I am writing in short form, addendum and dedendum. So what is the working depth, Anjali, in which the whole working is taking place? What is the working depth, Anjali? Working depth is little different. Working depth is not exactly equal to this one. Actually, this one is the total depth, na, Anjali? What is the total depth? Total depth is what? Addendum plus dedendum. Addendum plus dedendum. But we are forgetting the clearance also. We are
Yes, sir.
forgetting the clearance also. So whenever we need to calculate the working depth,
Yes, sir.
total depth has no use, na? We need to subtract the clearance also. Addendum plus dedendum minus clearance. Okay, actually. So where is clearance? Let me show you where is clearance. This vertical distance is clearance actually.
Okay. Yes, sir.
So let me show you, this red part is the clearance. So this vertical distance become actually what? Working depth. And what is the total depth? This is the total depth from top to bottom. From addendum circle to the dedendum circle, vertical distance is the total depth. And if we subtract the clearance distance vertical, then it becomes working depth. I think all the things are clear to you. What is face width, Anjali? What is face width? Face width is, sir,
Okay.
this distance is our
Yes,
face
sir.
width. This top is the top land part. This is the face of the teeth. This is the flank part of the teeth. Okay. What is circular pitch? The starting point of one gear on circular pitch and the very next gear starting point. So this starting point to this starting point. And you can also say that, Anjali, end point to end point is also circular pitch. Don't forget that. End point to end point is also circular pitch because the radial distance is same, na, Anjali? Radial distance is same. Tooth space and tooth thickness, tooth space, all the things are same, na? So that's why I can say that whenever there is another gear, suppose there is another teeth over here. So this blue part can only enter whenever there is this much space, na, Anjali? If this space is not equal to the tooth thickness of the gear number 2, then we cannot say that the gear would mesh or power transmission could happen. So here comes the small definition, which will be widely used in our numerical part. Whenever I am drawing the two circle in this way, Anjali, whenever I am drawing the two circles, but in this way, let me shift it over here. I think now it's okay. Yes. Whenever these two circles are drawn, it means they are pitch circles, Anjali. They are pitch circles. They are not gear. Okay. They are denoting the pitch
Yes, sir.
circle. And we need to show with them with the dotted line. So we can erase the remaining part also. We can erase the remaining part also in this way. You can say this. This part I'm erasing so that you can understand, sir, what is the value of the pitch circle. This is how two pitch circle touch with each other, Anjali. Okay. So
sir.
there is a common point, Anjali, over here. There is a common point. That point is known as, Anjali, pitch point. What is this pitch point? We will come to this later on. Suppose this is my gear number 1. This is my gear number 2. The center of this gear. This is gear number 1 and gear number 2. This is the pitch circle of the gear 1, and this one is the pitch circle of the gear number 2. So there is a common tangent, Anjali. There is a common tangent. Okay. There is a common tangent, you can say, at the pitch point. Okay. And that line is very fixed. Okay. So we can say that that pitch point will remain always present. And how the teeth are there? How the teeth are there? Teeth are there in this way, Anjali. Teeth are situated in this way. This, and this is how the other teeth are also measured. So this is how the teeth are there, but we will not draw the teeth. We will talk about only the pitch circle. So teeth meshing starts from one flank to the face of other gear. Okay, suppose this is my teeth number 1 for gear 1, na, Anjali. So this is my what face? This is flank, and other teeth is where? Other teeth is here. So the meshing will start from the, this is our flank, this is our face. So face to flank start touching initially, and later on it ends with the this part. This ends with this part. So this is my what? You can say root part of the gear, na? But I will call it as a what? Flank part. So flank and face start touching with each other. So two mating gears starts or you can say the meshing of gear starts from one flank to the face of the other gear. Okay, so now come to the basic definition. What is the first basic definition actually? That is circular pitch. In the diagram, we have discussed that what is the circular pitch. The circular pitch symbol is what actually? PC. P is capital, C is small. Okay,
Okay, sir.
and we know that the pitch circle diameter, there is a pitch circle diameter, na? That circle is imaginary circle on the center of the teeth of gear, and that pitch circle diameter is noted by the symbol D. Suppose there are number of teeth are also there, Anjali. Suppose number of teeth are denoted by symbol T. So circular pitch is the ratio of pitch circle diameter to the number of teeth in any gear. Okay, but I need to multiply one more thing, pi d. So it is the circumference of, you can say, the pitch circle, na? Pitch circle circumference upon the number of teeth. So this becomes the circular pitch. Okay, and remember one thing, Anjali, why I have specified the pitch point P in this diagram? Because this horizontal line is denoting the tangential force line. And always remember, Anjali, rotation always occur due to the tangential force. Vertical force is applying the thrust, and tangential force is responsible for our rotation. Okay, this is how the pure rolling starts in our gear. So PC is the pi d by t. And whenever two gears are meeting, suppose there are two gears, okay, these are the two gears and they are meshing, so 1 and 2. So this must be the condition that PC1 must be equal to PC2. Okay, otherwise meshing cannot be happen. So pi d1 by t1 is equal to pi d2 by t2. Pi will be cancelled out, so I can say that d1 by d2, okay, d1 by d2, na? Yes, is equal to t1 by t2. Okay, and remember this thing, that this thing is again equal to n2 by n1. Okay, Anjali, or I can say the reverse of it also. N1 is the RPM of gear number 1, N2 is the RPM of gear number 2, and that is equal to T2 by T1 is equal to D2 by D1. This is the form in which we need to remember the formula, and this formula is what, Anjali? Speed ratio. Speed ratio formula. Why? Because see, omega 1 by omega 2 is also there, na? Omega 1. What is omega, Anjali? 2 pi n1 by 60 upon 2 pi n2 by 60. So this thing will be cancelled out, na? The formula become n1 by n2. That's why omega 1 by omega t is the ratio of the speed, and the reverse of the speed ratio. Okay, suppose speed ratio is noted by n1 by n2, and n2 by n1 is known as, Anjali, what? Train value. There is a train value term in the gear train in upcoming chapter. Train value. Okay, somewhere in any competitive exam they can ask. Otherwise, this train value is not that much important. So speed ratio is very important. And in the gear train, I will tell you, we need to use the negative symbol for the reverse rotation and positive rotation, positive sign between the n1 by n2 and t2 by t1 for our the same direction of rotation as we have seen in internal gearing also. Okay, so now very important parameter you must have heard about, module. Have you heard about it or not? Module. So module is the symbol noted by small m, and this is the ratio of the pitch circle diameter d and the number of teeth. Okay, if I multiply by pi, then it becomes circular pitch. If I remove the pi, it becomes the module, and the d parameter I need to take in, Anjali, mm. Okay, and whenever two gears are meshing, this must be condition that m1 must be equal to m2. But for mating gears, if two gears are mating with each other, otherwise m1 and m2 could be different. Okay, Anjali. So now the you can say third parameter is there, na? Diametral pitch. Diametral pitch. What is this diametral pitch, Anjali? Diameter pitch is the symbol denoted by P, and D is the smaller symbol. So diameter pitch is the just inverse of the module. You can say T by D. Module was what actually? D by T, na? So now T by D is the
Yes, sir.
diametral pitch. But remember this thing, a diameter is not in mm, diameter is in inches. Okay, otherwise student
Yes.
used to remember incorrectly. And one every time they used to ask a question in gate and other competitive examination, they say that the product of circular pitch and diametral pitch is, they always used to ask circular pitch and diametral pitch product is what. Circular pitch was what actually? Pi d by t, and was diametral pitch t by d. Okay, t cancelled out, d cancelled out, answer will come out to be pi. That's a very most
Okay.
important question they used to ask in gate and other competitive exams.
Okay.
There will be option 1
Okay.
0 pi, none of the above. So if you know the definition, then you can attempt within a fraction of second, na? So now come to the fourth, that is our working depth, Anjali. And you know that word, what is working depth? Okay, what is working depth, Anjali? Addendum plus dedendum minus clearance, right? Or we can say that the sum of addendum of both bodies. Okay,
Okay.
sum of addendum of both the bodies is also known as our working depth. But generally we use this formula, addendum plus dedendum minus clearance. And now came the very important thing. You know what is this thing actually? Backlash. Okay, you, if you are a newspaper reader, you or better know that there is a leader over here, he gives some statement and there is a backlash for any film star or any leader's statement. What is this backlash? Backlash is the just after effect of something, na? If you say something
Yes,
wrong
sir.
and that produces the wrong impact on society, then it becomes backlash. Everybody trolled on Twitter, Facebook, and these things known as backlash. But in gear, what is this backlash and why we need to provide the backlash? To prevent the jamming of teeth, Anjali. To prevent the jamming of teeth. Why? Due to the thermal expansion. Why do we need backlash? To, this is the interview question, Anjali. To
Okay,
prevent
sir.
the jamming of gear teeth. I will provide you notes today. Don't worry. Gear
Okay,
teeth
sir.
due to thermal expansion, because the teeth are made up of brittle material. You can say cast iron and other materials are also there. So whenever there is a constant motion between them, there is a friction, and due to friction there is a heat, and they used to thermally expand. Okay, so I can say that to prevent the backlash, the tooth space minus tooth thickness, there should be some clearance also only. There must be clearance, because if suppose there are two teeth of one gear, there is a space over here, so the other teeth thickness should not be exactly equal to tooth space. There must be some clearance, na? There must be some clearance so that teeth can move freely. Otherwise what will happen? They start jamming. Due to the thermal expansion, the metal is start, you can say, expanding, na? Suppose this is my first teeth. Okay, suppose this is my one teeth, and due to the thermal expansion, this material, Anjali, this material try to expand. Okay, and suppose you have provided that much space, so that much space is becoming now less, na? So I cannot say that the other gear teeth can enter if it's so.
Yes, sir.
So we need to be very careful in our mind that we need to prevent the jamming also, na, Anjali? We need to prevent the jamming. So the tooth space minus tooth thickness is distance known as backlash. We always used to provide that distance. Okay, because always there is a partial sliding also, na? There is a heat. Okay, and due to heat, the deposition of metal on the, you can say, the profile of teeth is there. So tooth space, you can say, either increase or decrease. Sometimes it increase, sometimes it decrease. So due to that our gear cannot mesh with each other. Okay, so this is the important parameters. Now come to a very important thing, Anjali, that is pressure angle. Have you heard about it, Anjali? Pressure angle,
Yes, sir.
right? And very, very important. Actually, everything is important in mechanical. I cannot say that
Yes,
this
sir.
one is not important, but this parameter is very important actually. Pressure angle, the symbol is actually what? Phi. Okay, and what is this angle and where this angle is lying? Suppose this is my pinion teeth, Anjali. Small gear is there, and this is the pinion teeth. Okay, and there is an another gear also. Suppose there is an another gear, and it look like this. Okay, I'm not touching it. I'm providing the clearance. This one is my gear, Anjali. Okay, and this one is
Okay.
my pinion wheel. One is smaller in size, other one is bigger in size. So there is a line, Anjali. You can say that line is passing through over here. So there's a common point, na? Pitch point. That is a common point, pitch point. Through that there is a line, Anjali, and there is a force F, and that red line is known as, Anjali, what? Common normal.
Okay.
Common normal at which point? Q. There is a point, you can say P or you can say Q, because the see pitch point, the tangent which I drawn earlier, that tangent was this one, actually. That tangent was over here, but the red line is exactly perpendicular to that previous tangent line. So the red line is the common normal at Q. So I can say that this angle is also 90 degree. This angle is also 90 degree. So what is pressure angle? Pressure is the angle between the line of action and common tangent at point P. And generally the pressure angle is 20 degree to 25 degree. Let me draw another diagram so that you can understand it better. Suppose, Anjali, this is my pitch circle 1. Okay. And this is my pitch circle 2. This is my pitch circle 2, na?
Okay.
So I told you that there is a point, pitch point P, and from this point there is a horizontal tangent. There is a horizontal tangent. Okay, and the component which I was talking about is lying in this way, actually. So this line is what which I draw just now. Here is the F force. So the common tangent and this line of action line, this angle is known as, Anjali, what? Pressure angle. So I can say that angle
Okay.
between the line of action. Line of action is what? This green line, Anjali. This is line of action. Line of action. Sorry, line of action, and this line is common tangent. Common tangent. Okay, and there is a pressure angle term, and the P point is what, Anjali? Pitch point. Pitch point, na?
Okay.
Okay, so
Yes.
and we cannot increase the angle phi. We cannot increase the angle phi because F has two component, na, Anjali? F has two component. This component is what, Anjali? F cos phi, and that F cos phi is responsible for the pure rolling motion between the two gears. There is a sine component also, but that sine component provide the axial thrust from one gear to another. Due to that, the spur gear become useless. So that vertical component has no use over here. Only horizontal component has use. So we cannot increase phi because if we increase the phi, suppose, Anjali, because F cos phi is responsible, na? F cos phi is responsible for pure rolling, and if pure rolling is there, then we can call the body as gear. Otherwise, omega 1 by omega t is not constant, and there will not be accuracy. So the application of gear become useless. So if phi angle, some students say that, sir, why the value of pressure angle is only 20-25 degree? Why can't we take that 40, 45, 60, 80, 90? If cos 90 is there, Anjali, cos 90 is what, Anjali? Zero, na? So this whole
Yes,
component
sir.
will become zero. And if this component is absent, then we cannot say that the pure rolling motion could be there. This is the reason. And they every time they used to ask an interview, okay, that why we cannot increase the pressure angle value. Got it? So
Yes,
up
sir.
to here, they will ask the theoretical and some small numerical part, and they can make the one marks question or two marks question, because 5 marks question is there. Na, they can ask anything. We cannot say that the